It is not that the NCERT is not telling you what is required. It is absolutely telling you. They will pick up things from the NCERT also. Wegener believed in the three-layer system of Edward Swiss. This is basically the representation or a handmade diagram of continental drift theory. Don't be a person who doesn't want to work hard and simply just copy these things. Don't do that. This does not mean that every theory that is mentioned is completely correct, or there are no flaws. That is completely wrong. These basic things form the core of your understanding for civil services. Hello aspirants, welcome to PW OnlyIAS. I am here Harpreet Singh with the third lecture of the Physical Geography series. Please remember, though, as I've already mentioned, this is an NCERT series, but we are not going to confine ourselves to the NCERTs. We are further going to go into the details of the concepts that have been mentioned in the NCERT but not explained. So this will fill the gap between what the NCERT says and what is the demand for the civil services examination. Hopefully you enjoyed the previous two lectures of the physical geography. We are going to build or carry forward those concepts in this particular lecture. So let us begin with this interesting third chapter of the physical geography series, that is distribution of ocean and continents. Please remember, students, that this is a Telegram account where you can find the PDFs. You can find regarding the lecture that I have given over here. Along with it, a lot of guidance regarding geography as a subject, anthropology optional, society, and civil services preparation in general. Now, one more very important announcement. Very often students ask me, sir, where can we find the notes which you have written on the board? Please remember, you can enroll on the free batch, NCERT batch. The links are going to be given in the description box. You enroll yourself, you're not charged anything. It's completely free of cost. And from that link, or with respect to the lecture, you can basically download the lecture. So please enroll in this free batch. This is for everybody who wants to study free of cost for you all. But there are certain students who want to enroll in the batches with proper preliminary, mains, and interview preparation in a comprehensive manner. So you have the batches over here. The Titan batch for those aiming for 2026, that is for 10,999. Along with it, those aiming for 2027, the 2 years batches there, that is Pinnacle, that is for 13,499. Having said that, let us begin with today's lecture of the distribution of ocean and continents. Please remember, now just have a look here. This is a map, again, as we have already seen, a hand-drawn map. Many people say that it is not hand-drawn. It is definitely a hand-drawn map, which I have been continuously practicing, showing you also in front of you that how we can draw these maps. Now see, what I have marked in green is basically representing the continents, right? You can see over here Antarctica also, Africa, Asia, Europe, Australia, South America, North America. That means the continents, that means the land. In a simple words, land. What is marked in blue or in dotted, I've just dotted these places. So this is basically referring to water bodies in the form of, let us say, oceans, seas. Now, based on this observation which you see here, there are certain inferences that we can draw. Now, let us see these inferences and then we will build on these concepts, how these continents have originated, how they're possibly moving. So there are a lot of concepts that are very important for your prelims as well as the mains examination. Let us see them. Looking at this, let's build some concepts. If you see, there are certain observations I've mentioned. If I take the total surface of the earth, water basically comprises 70.8% of it, while land 29.2. So if, let us assume, this is a complete sheet. Please remember, when we actually depict them on this model, 2D model, it becomes really little difficult because when you see a globe, you have a better aspect of viewing how much water cover is there on the surface. Because obviously over here, we cannot mold it into a globe. But based on the observations, based on the measurements, if you see, basically water covers 70.8% of the surface, whereas land covers only 29.2. Now this something is very important. This particular sentence itself is important because this was asked in the CAPF also examination, that is also civil part of the UPSC examination. This statement has been asked, I think, 10 to 15 years back also, along with the other statements. So these basic things form the core of your understanding for civil services. Let us assume if you haven't read them. Possibly they'll mention 60%, possibly they might mention 85%. at that particular point of time, there is quite a possibility that you might make certain errors. Now, this is based on the new reports that have been there. So, we will follow this standard format. More than 75% land is in the northern hemisphere. Now, if you see, this is the equator. Large patches of land that you see over here. So, that means based on the observation also, if you see, you can say 75% of the land is in the northern hemisphere. Now, these can be themselves as statements that can be asked in your preliminary examination. That is why you should be well aware of them. Third, North Pole is surrounded by water while South Pole by land. Now, the reason is we have done the mapping video of Antarctica. You know that very well. Antarctica is a land mass. It is a continent also. So, this is Antarctica. Now, it is land and the South Pole is located over there. When you see the North Pole, it is basically Arctic Sea. That is why if you see, North Pole is surrounded by water and South Pole by land. Now, again, an important statement. Sometimes in the hurry while you are basically writing your answers or marking your answers for the preliminary examination, you might make some mistakes. So, you should be very well aware of them. Continents roughly triangular in shape except Antarctica and Australia. Now, this is again this statement has basically been made by few thinkers who are geographers. So, they have said roughly they are in triangular shape except for these two. So, this can also be a statement like generally observed the shapes of the continents are triangular. Now, at that particular time in the prelim examination, you will say, no, it is not, we will mark it wrong. Generally, it is not saying every continent, it is saying generally. So, this statement will be right in that case. So, that is why please remember, these all statements become very important for your brief understanding based on the observations that you have made here. Clear? Please remember, along with this, you know that along with the geography series, we have a mapping video that comes every week. So, that will be complementing the understanding of your mapping, right? Let's move ahead. Now, please understand, when you study the NCERT, in the NCERT, you will see that the theories that are mentioned basically are the continental drift theory by Wegener, that also in 2 paragraphs. Then they basically mention in 1 sentence the convectional current aspect. Then in 2 paragraphs, they mention seafloor theory, and then they mention the plate tectonics, that also in very brief details. So, it is difficult to comprehend. Now, please understand, it is not that the NCERT is not telling you what is required. It is absolutely telling you. They will pick up things from the NCERT also. But remember, there are a lot of things that are missing. Now, these things are often asked in your mains examination also. Now, for example, please remember there is a PYQ, previous year question, which talks about continental drift theories. In that case, you could have mentioned there is another continental drift theory by Taylor. There is another theory by Wegener. There have been questions on this. Repeated questions have been asked on plate tectonics. Repeated questions have been asked on seafloor spreading. So, that is why please understand these concepts become very important. Now, I have mentioned even those theories which have just been mentioned and not explained. So, it is your task to use this lecture very precisely, very religiously, so that you note each and every detail while making the notes. I am requesting you again, please do not go with the fact that you will just download this particular PDF and write everything down. Remember, you will miss a lot of things because there is no dearth of material in the market. If you are simply behind market that, okay, the lecture has come, let us download, who will see the lecture? This is again one of the wrong strategies which students adopt, because there are a lot of things which I'm going to speak and explain which will not be mentioned in that particular PDF. So, using the lecture along with the PDF becomes very important. Clear? So, please let's move and study all these. There are a lot of views or theories for the evolution of ocean and continents. Now, one more thing before we begin. This does not mean that every theory that is mentioned is completely correct or there are no flaws. That is completely wrong. Even the latest plate tectonics theory is not completely correct. There are a lot of issues. Similarly, when you will come across or read these theories, which I'm going to explain to you, you will see, like for example, the tetrahedral hypothesis. This is again a very basic student of class 10 can also say this is wrong. But it does tell you something or some concepts which help you to build the other theories. That is why whenever you read theories, first understand what the person or the thinker who has given the theory has told you. After that, criticize that, right? That this is a possible criticism. So, based on these, this is a particular flow in which we're going to study. So, let's begin. First is the tetrahedral hypothesis by Lothian Green, 1875. Then you have the continental drift theory by Taylor. Please remember, there are 2 continental drift theories. Before Wegener, which you read, Taylor had given the theory. So you should be aware of that also. It's quite possible that in the examination they might ask you, give the continental drift theory by Taylor. They can ask you, because nowadays in general studies also they are asking such questions. Continental drift theory of Wegener has been asked repeatedly. Give the evidences also. That is also covered here. We'll see that. Then this convectional current theory. Please remember, to understand the plate tectonics, you need to go through and understand the continental drift theory, the convectional theory, and the concept of seafloor spreading. When you understand these things, only then plate tectonics theory will make relevance or importance for you, right? So let us begin. Let us begin with the understanding. Okay. First theory is tetrahedral hypothesis. Now, please remember, in order to understand what is tetrahedral hypothesis, this is a diagram that I have made in front of you. You should first understand what the diagram is. Leave these two for 2 minutes. Let us assume you have a 3D figure in which there are, let us say, 4 triangles. Let us see this. Let us say there is a triangle. Supposingly you have a cardboard box. Let us make it clear. You have a cardboard box which is in triangular shape. This is also a triangle. You close it. You close it from here. You close it from here. Do you realize that you will form a tetrahedron where it is made up of 4 equilateral triangles? This is also an equilateral triangle. This also, this also, this also. Now this is supposingly the base, right? And I close this, and I close this, and I close this. What will it form? It will form a structure of this form, where the base is also an equilateral triangle, this is also an equilateral triangle, this also, and the back end also. So there are a combination of 4 equilateral triangles which is making this particular figure. Now this figure can be made based on these 2 things. Either you can close this, you can form, or you can combine and fold this, then also you can form an tetrahedron. There was no need to draw this, but I've just shown you so that how you can basically conceptualize the shape of a tetrahedron. Again repeating, tetrahedron basically is a figure that is formed by basically joining 4 equilateral triangles. One equilateral triangle at the base, then merging it, let us say closing this, closing this, closing this. And the figure that is formed, this is known as a tetrahedron, right? Tetra means 4, right? Now see, let us understand, you've basically understood what tetrahedron basically means. Now let us understand the theory. Tetrahedral hypothesis by Lothian Green, 1875. This hypothesis is based on tetrahedron, which is a solid body of 4 equal places surface, each which is an equilateral triangle. So they have the equal plane surfaces. They are equilateral also. So this is combining them forms this tetrahedron. Clear? Now please understand. Right now again, forget the fact that Earth is in which shape. Forget all those facts. Just understand what the theory is saying. So it is based on the fact that there is a tetrahedron that is existing, which is basically formed because of the 4 equilateral triangles that have been basically joined. 1 at the base and 3 are joined at the top, so that it forms a 3D figure. Clear? Now this is the premise on the basis on which this theory is given. Now, having understood the shape, let us begin with the fact that he gives a particular view. Now for 2 minutes understand this very, very well. This is a shape in front of you. Now how you need to imagine it, you need to understand this. Let us assume I take this shape and turn it like this. I reverse it. When I reverse it, do you realize there will be a plane on the top? Yes. Similarly, what is going on here is, supposingly the base, the top which was pointed is pointing downward, and this is a top part which I have reversed. Now what this theory is saying is, basically it is marking certain points that the continents are present in certain regions and the oceans are present in certain regions. Please again conceptualize. Reverse this particular shape. You will have a base on the top, and this is pointing down, and obviously this is pointing outwards, right? Now he said that this is possibly a depiction of Earth. Now how he's saying, let us first of all see the points. He says that Earth was earlier a sphere, a spherical shaped body, but later on due to cooling a tetrahedron was formed. What does Lothian Green say? He said that earlier the Earth was a sphere. But as the cooling of the Earth took place, it formed a tetrahedron shape. Now, you would be imagining how stupid this person is possibly, that we can see our Earth from the satellites, we can see from the spaceships, we know it is not in a tetrahedron shape. Yes, those are the criticisms. Right now, what Lothian Green is assuming is possibly it is in a tetrahedral shape, right? Now, tetrahedron. Now, epics are the continents or land and flats are the oceans. Now, see epics, what does it mean? That means this pointed sides. Now, this is Europe, one pointed side. This pointed side is Asia and Africa. This pointed side is North America and South America, and this pointed side is Antarctica. That means the pointed or the apex positions are the continents and the flats are the oceans. Now, how you can assume this? He's possibly saying this region is the Arctic Sea. This flat region is the Arctic Sea. This flat region is basically representing what? The Atlantic Ocean. This is possibly representing the Indian Ocean. Now, you are forgetting one more thing, that there is a backside of this, backside of the tetrahedron. That backside is represented by the Pacific Ocean because Pacific Ocean is larger according to Lothian Green. So what do you see? The pointed sides of this 3D figure are represented by continents and the flats are represented by the oceans. See here, supposing that these pointed things are representing what? The continents, and the flats are representing the oceans. That is what? I've just reversed the diagram as according to the Lothian Green's view. So these flats, this is Arctic Sea, this is Atlantic Ocean, this is Indian Ocean. Backside, if you go, that is basically what? The Pacific Ocean. The pointed sides are Asia and Africa. This is Europe, this is North America, South America, this is Antarctica. Now, this is what is the view. Now, you will say there are a lot of errors in that. Yes, there are. But this is the view that is presented. Clear? Again, it was earlier sphere, then later on due to cooling, tetrahedron was created. Epics are the continents or the land, flats are the oceans. Back represents the Pacific Ocean, as I've shown you. Behind this, the side that is present, that equilateral triangle, represents the Pacific Ocean. Clear? Okay. Having done this, you very well know, this sounds very funny also that somebody is creating such theories, but again, there were lack of observations from the perspective of, let us say, spacecraft, or we going to space and observing. So that is why these theories during the initial times did basically rise up and people started popularizing them also. So leaving that apart, we should understand that balance of Earth cannot be maintained if it is in a tetrahedron shape and it is basically revolving or rotating in that particular manner, right? It shows permanency of ocean and continents. It shows that the ocean and continents are permanently fixed there. And you know in today's time also they are not fixed. They are moving. The latest plate tectonics theory said that the plates are moving. And the third, which I have not even written, is basically when you go to the space and you have photographs of that, Earth from nowhere is similar to the shape of a tetrahedron. It is a geoid shape, right? So we all know. So this is again, you can write the third, you can write even the third criticism, that it is not a tetrahedron as tetrahedral shape because it is being observed through the various satellites, through various imageries, that this is not the correct shape. So this is the first view, which is basically the tetrahedral hypothesis, which you should be aware of. In the NCERTs and old NCERTs also, they have basically mentioned this word, not even explained, which I have explained you what it basically means. Now moving on to the second view aspect, that is the continental drift theory. Now please understand, when we will do the plate tectonics also, you will understand it completely. What the perception of the people who have given continental drift theory is that what happens actually, according to them, is because they believe that continents are moving. There is no doubt in that. The only thing is because they see continents are above the sea level or the ocean, so that is why the part that is moving, they assume that only the continents are moving. Later on, plate tectonics say that the plates might be extending even till the ocean level also, though those plates are moving, not merely the continents. This is a very important difference that you will understand once you have done all the theories. Over here, the continental drift theory, either by Tyler or Wegener, they're basically talking about the continents which are moving. Clear? Let's see. So this is the older continental drift theory. The newer one is Wegener. In case, supposing a question is asked in 10 marker about continental drift theory, generally they ask in 15 markers only. And in that case, your preference will majorly be on Wegener, but you can also mention about Tyler's theory. There is nothing wrong in that. You will be awarded more marks only. So you should be aware of both the continental drift theories. Now see, what is the main purpose of this particular theory? Now see, these I have very systematically arranged: the purpose, their theory statement, the diagram, the criticism. So this is the pattern in which you write in your mains examination also. And when they ask you in the prelims also, if you have this knowledge, you will be able to answer all the questions, right? What is the main purpose? The hypothesis tries to explain the origin of folded mountains in the tertiary period, like the Rockies, Andes, and the Himalayas and the Alps. Now, you know that very well that these are the young fold mountains, the Rockies, the Alps, the Himalayas. So, these are young fold mountains. So, basically, Tyler wanted to explain how these mountain ranges basically originated. This was his main purpose. In order to fulfill that, he has given this theory. That was his purpose, right? Now, let's see. Theory statements. He says that there were two land masses during the Cretaceous period. Cretaceous period is basically from 64 to 144 million years ago. Now he says there were two land masses, one land mass and two land masses. Now the thing is, one is Laurasia and other is Gondwana land. Laurasia is located near the North Pole and Gondwana land near the South Pole. So if you see that diagram over here, this is the shape. It says that one landmass is located near the North Pole and other close to the South Pole. And this is known as Laurasia, the northern one. And this is the Gondwana land, which is the southern one. So this is being presented, this view is being presented by what? Taylor. Please again understand, these things do not assume that, okay, this is only has happened. No, because we are studying the various concepts and slowly, we will be knowing the advanced concepts also. So just now, please assume that this is what the thinker is saying. It is not necessary that this might have happened. Please remember that, right? So this is Laurasia located in the North Pole, and this is the Gondwana land located in the South Pole. So now when you are drawing the diagrams, have drawn all the diagrams, so that makes it easier for you to remember also. Now, Taylor says that there are two movements or two basically types of forces, a force is being exerted there, so that there are two types of movement that are taking place. One is the equatorial side or equatorwards movement. Now, both the bodies are moving towards the equator. So that means there is equatorwards movement. Second is, along with it, there is westward movement also. So there is westward movement also. So there are two basically ways in which the movement of the land masses are basically taking place. Now please remember, when you see this thing, it says basically this is the landmass, this is the landmass, other parts are completely covered with water. And two forces being exerted, one equatorwards, one westward. Now what happens is, the driving force responsible for both the movement of the tidal force of the moon. So the force that is exerted by the moon, which is known as tidal force. In a way, you can call it a gravitational force also, but the word is tidal force. The tidal force that is being exerted is causing these two types of movement. Now, right now you'll be saying, how is it possible? But you just have to understand what the thinker is saying right now. So they say that this is a force being exerted. The moon is exerting the force, which is basically causing the landmass to move towards the equator and towards the western side. Clear? Now see, according to Taylor, during the equatorwards movement, the continents were deformed and their edges forming large lobe-shaped folds and mountain ranges. So what is he trying to say? Because he wanted to explain the tertiary mountain ranges formation. He said while moving towards the equator, there was a lot of deformation within the continental masses that took place, and that basically caused the formation of mountain ranges. He did not go into a lot of detail. He simply said because of the forces of the movement of the continents towards the equatorwards, there was deformation of the edges of the continent. Obviously, he assumes that because the movement is taking place, there will be again deformation at the edges, particularly because it is moving down, and that led to the formation of what? The mountains, particularly the ones which are mentioned during the tertiary period, right? Now the criticism, please understand, you by default know that there is a lot of issues with regarding to this theory. Taylor made the continents move to great extent to explain the mountain formation. So the criticism is that just to explain the mountain formation, you have completely moved all the parts of the continent here and there. And it is not necessary that such processes might have taken place, or to such scale it might have taken place. Second is, tidal forces are not so strong. He said, see, tidal forces or the gravitational pull of the moon can be okay and play an important role. It can form tides, Yes, there are certain these forces exerted can impact to certain degree, but it cannot cause complete continents to move towards the equator or even move towards the western side. So that was a very big exaggeration with respect to these forces, or that these forces can cause such massive movement on the surface of the earth. Next is forces within the earth have not been considered. So just remember, today's time we know that there is let us say convectional currents in the mantle, what is basically one of the reasons for pulling the plates and all. While in that particular case we are talking about the internal forces which are responsible for such movements taking place. Have all those factors been taken in this theory? No. They are not talking about the internal forces might be responsible for such movement. That is why this is very heavily criticized. They said you have mentioned about an external force which is causing. What about the internal forces? Similar problem is with Wegener also. You will be seeing that. So this is again the third criticism. Clear? So we have done with what? Two theories, tetrahedral hypothesis, and then we have done with the continental drift theory by F.B. Taylor. Now, when we have done this, we come to the third theory, which is again very commonly explained, mentioned also various places, and this is the one which is generally mentioned as continental drift theory. People neglect Taylor's theory, but again that will be incomplete. You should be aware of the continental drift theory by Taylor also. Now what does he say? What does the continental drift theory of Alfred Wegener say? Now please understand, what is the main purpose of this particular theory? There is again, whenever a theory is created, or let us say presented, there is something in the mind of the thinker or a geographer for that matter. In this case, they want to explain a concept. In order to explain that concept, they create a theory, and obviously then it becomes public that these theories have been presented, those views have been presented. So there is always a purpose. So what is the purpose here? The continental drift theory grew out of the need to explain the variations in the climate in the past. This is again very important. This can be asked also, right? He wanted to explain how the variations in the climate basically took place in the past time. Let us say thousands of years back, more than that. So there were variations in the climate. How did it take place? Now see, there is an assumption that Wegener takes. Wegener says that he assumed, that means he's assumed that this is the fact that has happened, and based on this assumption, I'm going to give my theory. He says that the continents were moving while the climate belts were stationary. He says that the climate belts that are there, that certain climate is in certain region, that is fixed. Only the continents are moving. So when a continent moves and come to that belt region, that continent will be experiencing that particular climate. When that continent moves and another continent comes to that region, that continent will experience that climate. So he says that the climate belts are stationary, but the continents are moving. Now this is the assumption that Wegener basically takes in order to give his theory. Two things you have done: the reasons why he wants to explain what is the purpose. Second is the assumption that he takes. You can copy it if you want, right? Continents are moving while the belts are stationary in nature. They are not moving, right? Now, when we move ahead, let us analyze the theory statements. You've already done in the previous lecture what is Sial, Sima, and knife. So what he does is, Wegener believed in the three-layer system of Edward Swiss. His first statement is that he believes in the concept that was given by Edward Swiss. That means that there are three layers in such form of Sial, Sima, and knife that are existing. Now, this is his first statement in his theory. And you have already studied what are the densities, what are the compositions and all in the previous lecture. We're not repeating it here. Neither you have to mention it, because you just need to mention that he believed in the concept of Edward Swiss, right? Next. Wegener considered Sial to be limited to the continental masses. Now see, understand here. These statements which have been mentioned, you know that very well there are ratios in that, you will assume. Just remember what the statements are being said, those are more important for you. Right? Now see here. Wegener considered Sial, that means made up of silica and aluminium, to be limited to the continental masses, whereas oceanic crust were represented by upper part of Sima. So that means he is trying to say that the Sial is basically limited to the continental part only. The oceanic crust basically, because it is thinner, he assumed that the Sial is not present on the oceanic crust, only in the continental crust. This is what he is trying to say. Clear? Now, all the land masses were united in the form of one land mass known as Pangaea. Now, please see. He, in contradiction to the view of Taylor had mentioned there is Laurentian on the top, North Pole, and Gondwana land on the South Pole side, right? And they were moving towards the equator and westward. Clear? Here, he says that there is one landmass. This is the landmass and all other parts of the earth are completely covered with water. This landmass is known as Pangaea, and the complete large water body or one ocean that we say is known as Panthalassa. What? Panthalassa. Now see, there is something very important here. When you read Tyler's theory, you will see something very important. He talks about these movements taking place during the Cretaceous period. That means 64 to 144 million years ago. This is the time. While Wegener's theory talks about Carboniferous period, that means these movement which he is talking about is during the Carboniferous period. That is from 286 to 360 million years ago. Now coming back to the statement, first he said that he believes in the Edward Swiss classification, the chemical classification that is given of the earth of Sial, Sima and Knife. Second, he says that the oceanic crust does not have the Sial, it only has the Sima, the upper layer of the Sima. And that means the Sial is basically confined to the continental crust. Now second thing he says that there is a huge landmass that is existing, one united landmass, that is Pangaea, and the complete other parts of the surface of the earth are covered with water, and which is basically Panthalassa. So that is why it says that all the land masses were united in the form of one huge landmass that is known as Pangaea in the Carboniferous period, that is 286 to 360 million years ago. And there's a huge water body known as Panthalassa. That means other parts are completely covered with water, one water body, right? Now this is the basic thing. Now let's see. Now please understand, this is basically the representation or a handmade diagram of continental drift theory. This thing started breaking, and then 225 million years ago, you will realize that there is certain breaks that are taking place. These continents further started moving apart, and you see this part is moving up, this part is further moving downwards. Then you see 100 million years ago, you will see there is further separation taking place. This will form the North America, this is South America, this will form Africa, this will form Europe and Asia, and this is the peninsular part of India which is moving and it will crash into the European plate. And this is Antarctica. When you finally come here, you realize that this part has formed this part has formed South American part, this part has formed your what we say as your Africa, then other parts of Australia, Antarctica, and so on and so forth. This is the continental drift theory basically talking about. Now, this is all handmade. Now, you will say, sir, it is very difficult to make such precise. Please understand, you don't have to be artistic in your approach while you're making the diagrams in the examination, but at least it should not look like a way that it is not even close to what is being represented. At least try. Please remember, the more you practice, better you will be at drawing these diagrams. If I have made in front of you, so possibly you can also. If you draw it twice and thrice, possibly it will be ingrained in your mind. Please remember, very often people assume that while drawing these diagrams or the maps, it takes a lot of time. Let us avoid it. We can do it at the later stages. The problem that is, because of not drawing these diagrams or maps, you are not able to comprehend the concept, nor you are able to remember them. The students who make these diagrams are able to remember the concepts also very well. Now just remember, other things, whether it was Pangaea, Panthalassa, Sial, Sima, everybody will basically be able to remember them. The one who draws the diagram somewhat similar to this will be able to gain at least 1 or 2 marks more in the examination. A direct question has come, I think twice or thrice in the past 10 years based on continental drift theory. Straight away asking what is continental drift theory, how the oceans and continents are moving apart. What are the evidences in support of that? Now, this is a complete answer which I'm writing right now is a complete answer that gives you out of 15 marks, it can give you even 11 marks if you write it properly. These are low-hanging fruits, so please remember that. Now see, from this part to this, to this, to this, to this. So what do you see? That one combined Pangaea is breaking, moving because of what? The tidal forces. We'll see the forces also, obviously. We'll see the forces because of which it is moving, and because of that, it finally takes this form. We'll see the forces also, don't worry. Now see, over here, he says that Laurasia consisting of the present North America, Europe, and Asia form the northern part of Pangaea. Now please see, he also uses the same word of Laurasia and Gondwana land. When this Pangaea started breaking, the northern part of it was known as Laurasia, the southern part of it was known as Gondwana land. Please remember, what did Taylor do? What did Taylor do? Taylor basically already supposed that the Laurasia was on the top and Gondwana land was in the south. But what does Wegener do? Wegener combines it that there is one landmass, and this landmass possibly, let us say, broke. The broken upper part was known as Laurasia, the southern part was known as Gondwana land. And then what does he say? You will be seeing these countries, all these countries will be part of what? The Laurasia, the southern, this part will be what? Part of Gondwana land. That is why he says that North America, Europe and Asia form the northern part of Pangaea. See for yourself, this is again, this part will form what? North America. You will see this part will form Europe part, this will form Asia. So in a way, they are representing or saying the same thing, but from a different perception. So northern part of this Pangaea, when it broke, formed the Laurasia, southern part formed the Gondwana land. Clear? Now let's move ahead. Now the southern part formed the South America, Madagascar, Peninsular India, Australia and Antarctica. This is obvious. Now Pangaea was disrupted during the subsequent periods and broken land masses differed, or let us say moved away. Now please remember, again, they're talking about that as Pangaea broke up, various land masses started drifting, firstly in form of a broad mass, Laurasia northern part and Gondwana land the southern part. Those land masses further started drifting apart and started breaking, and that led to the formation of what is known as the various continents or the smaller land masses, which you can see over here according to Wegener. From here, further breaking of parts, further, see this further broke up into African part and what? South American part. So this is separated. Then finally this. So there is certain repeated breaking and drifting that is taking place. Now please remember, what are the forces that are taking place? Now these forces or the names that have been given, see certain books simply mention that yes, the tidal forces are responsible, right? Tidal forces are responsible, again a similar view. Certain books also mention that there is an equatorwards or movement that is taking place that is due to the gravitational differential forces, due to the differences in the gravity in different parts of the region. And second is westward movement is also taking place, that is also due to the tidal forces. So this is very similar to what we have basically seen in the view of Tyler. In a way, if you want, you can basically say that there is similarity in the Tyler's and Wegener's view, where when you're talking about when the movement is taking place, certain movement is again westwards, some which equatorwards, some let us say moving towards the other direction. So there is again a problem. First of all, these forces which are mentioned here do not comprehensively cover all the directions that are possibly taking place. It is not only towards the equator or only towards the west. There are other directions also in which the continents are moving. So the problem over here is this is not comprehensively basically telling us that. The major thing it is telling is that there is differences in the gravity which the continents which are undergoing. That is because of the differences, the land masses are possibly breaking and moving apart. That is why this is mentioned as equatorwards force. And then westernward direction certain continents are moving. That is because of the tidal forces or the gravitational force of the moon. Again, this is a very limited point and a wrong statement also, but we will not comment on it right now because we have to understand what the thinker is saying right now. Clear? Now let's see. When he stated this statement, this is a theory. Now he gives certain evidences to prove that, see, what my theory is, it is completely correct. Now what is the theory? Please understand. First evidences that he says is juxtaposition of continents. He gives evidence that, see, what I have said is correct. See the theory, see the evidences. Juxtaposition means that if I bring Africa and South America close, they will almost like a jigsaw puzzle fix with each other, right? Why? Because he showed that, see, over here, they were almost together, and that is why later on they separated. So if he gives this evidence, he is trying to show that my theory is correct. So juxtaposition is this, that they will like a jigsaw puzzle basically join together if we bring the continents together. So the shoreline of Africa and South America facing each other have a remarkable and unmistakable match possibly, because they can basically almost fix with one another according to what? Wegener. So this is known as the juxtaposition of continents. First evidence. Second, rocks of the same age across the ocean. Now there was certain dating methodology. Dating means to find out the age of the rocks. When you find out the age of the rocks of surrounding, let us say this North American part, Greenland, Iceland, European part, African part, these regions, they are of almost the similar age. Similar age that is close to 2000 million years ago or old. This is quite possible only if supposingly they were close to each other as one landmass. So this is also an evidence that is presented by Wegener in his theory. So that means similarity in the age of the rocks. You can draw these diagrams also. Please remember, I have drawn all these diagrams by hand. Many people, many aspirants have come across while teaching online, offline. People say, sir, everywhere the books have basically drawn the diagram, and those printed books, diagrams and maps are there, and it is not possible to draw because the teachers just show us the map and they expect us to draw, while they themselves possibly don't draw. That is why, in order to resolve that problem, every single map has been drawn by hand, every single diagram is drawn by hand. You will see after a few slides the level of diagrammatic representation that I have made. Now, so that is why please don't be lazy. Don't be a person who doesn't want to work hard and simply just copy these things. Don't do that. Work hard, repeatedly revise these things, repeatedly make these diagrams. You should improve your abilities and capabilities if you want to qualify this examination. Remember that very well. UPSC will never ever come to your level. You have to reach the level of UPSC in order to qualify this examination. I always tell them in my batches also, my geography lectures also, society lectures also, or even when I'm going offline. It is basically a basic understanding that if you do not match the UPSC, they're not going to go to your level to possibly match that level. Please remember, it has a standard, it maintains that standard. When your copies are being checked, they do not know whether you come from a rural background or an urban background, whether you are educated from St. Stephen's College or some other college, whether your medium is XYZ and you're writing in some other medium. They do not know. They simply have a copy in front of them and they're going to check it. Now, please understand this. We might make excuses for the fact that this happened to me, this is a reason, that is a reason. In front of the examiner, they are not going to tolerate that. Please understand that very, very well. Okay? Having done this, we have done justification of continents, rocks of the same age across oceans. Next is the tillet. Now, please remember, we will be seeing these tillets or understanding them in detail when we will be doing the landforms, particularly the glacial landforms. So, these are sedimentary rocks that are formed out of the deposits of the glacier. So, these are glacial deposits, right? Particularly, these deposits are formed in the glacial regions, but if they're found in other regions, that might be possible because those regions might have undergone ice age. And that is why certain deposits might be present in certain regions. So when we observe that there are tillets deposit found in this region of South America, this region of Africa, Antarctica, Australia, and Deccan peninsular region of India. This basically explains us that possibly when this continent was one, there would be, let us say, and at that time, let us say tillet deposits might have been made during that time. And similarly, this is a particular pattern in which when we bring the continents, let us say in this shape, we will say it is forming like a shape over here. And these tillet deposits are formed. So they said possibly this is one of the reasons that the continents, these continents which we study together, were possibly together. And that is why we see this specific pattern, this pink region where tillet deposits are found, because they were together. So this is one of the other evidences which is being mentioned by Wegener. Next evidence is placer deposits. Now see, these deposits are of sand and gravel in the bed of the river. Sometimes valuable minerals like gold are also associated with it. That is why when you, let us say, combine certain, let us say, bring these continents together, you will see certain regions which are very close, which have placer deposits. Now, it says possibly because during the old times when the continents were together, possibly some flow of rivers were taking place because it was one landmass, and that is why these deposits of, let us say, gold and all are found in these particular regions. Because I said, these are deposits of the sand and gravel which generally contains valuable minerals, particularly like the gold. Not necessarily gold, it can be others also, but placer deposits are majorly associated with a terminology or mineral with gold. It can be others also. So that is why possibly that these are the regions when if we bring them together, you can see in Indian peninsular part also, Australia also, South American and African region also. So possibly it was one, there were rivers flowing, these deposits were made, and that is why when the continents separated, we still find the evidences of these placer deposits when presumably this continent was one. Let's move ahead. Distribution of fossils. See, now there are a lot of fossil deposits that are found of animals and animals and plants. Now, I have mentioned few of them. You can remember one or two, it will work. Like we have Cyanogathus, we have Glossopithecus, we have Mesosaurus, we have Lastrosaurus. So, if supposingly, based on the evidences of the fossils that are found, let us say we found certain evidences of Cyanogathus in these regions and this region. We found certain evidences of Glossopithecus over here, 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 and here. So, if you bring the continents together, it will form like a bridge possibly where the animals might have migrated. Or let us say certain plants are present in certain regions. So, this shows us possibly this landmass was one, and that is why we have certain animals or evidences of these animals common to these particular regions, if presumably they were together. That is why this forms a very important evidence for the continental drift theory by Wegener. Now, you don't have to remember all of these names of these fossils. You can presumably remember one or two. It will be more than sufficient. So, these are the 5 evidences that have been presented by Wegener. Now, the problem that arises is it is full of problems in a way. We have already seen. Let's see them. First, lack of mechanism. See, Wegener could not explain a satisfactory mechanism how these continents are moving. Merely giving the name of gravitational differential or the tidal forces does not basically give you a proper mechanism. He has not explained. He's just mentioned them and said that they are moving in order to satisfy his theory. But he's not explained any proper mechanism. Next, ignored the oceanic crust. Now, Wegener's theory mainly focused on the movement of the continents, and it did not adequately account for the behavior of the oceanic crust. The problem is that the scientists of these time presumably assumed that because they could see only the continents moving because they were above the water level, so possibly they assumed only the continents moved. They had no mention about the oceanic crust, and that is again a very big flaw which you later see plate tectonics basically covers up because it considers the concept of plate rather than only the continent, right? No complete justification. Now, when we see over here, we see that there is justification, but if you bring it together, you will see it is not a complete justification. So, many thinkers and geographers have said that this statement is absolutely wrong because by merely having a shape that is similar, which could fix or little bit fixed, does not mean that they were possibly the part or they were together. So, this is again a very important criticism that has been made over here. Wegener did not elaborate on the direction and sequence. Now, he was very random. He mentioned about the equator word, he mentioned about the westward, similar to Tyler, but he did not go into further detail because the problem is those were not the only direction in which the continents were moving. So, he did not elaborate in that. That is again a very, very important or let us say major issue that is present in this particular theory. So, this is the fourth problem or the criticism here. So, let's move to the next concept. We have done Lothian Green's concept of tetrahedron hypothesis. We have done continental drift by Taylor. We have done continental drift by Alfred Wegener. Now comes the convectional current theory or concept by Harry Hess. Now, this is something very common, very to understand, very easy to understand, very important also. We have done in the previous lecture the concept of what is lithosphere, asthenosphere and all. We have already done what is the crust, what is mantle and core. We have already done those parts in the previous lecture. So, I'm not going to repeat those concepts. Using the concepts basically from what we have learned in the previous lectures, I'm using them here. Now, let's see. What is the main purpose of this theory? To explain the Earth's lithospheric plates and the dynamic processes that shape the Earth's surface. So, he says that the lithosphere movement has to be explained. So, possibly in order to explain that, he gives this particular theory, that is the convectional current theory. So, this is the major purpose. Now, see what is the process. Now, please see here, I will be showing you the diagram. Let me explain you the diagram in 2 minutes and then possibly you will be able to understand it well. Now, see. See the core over here, you know that it is very hot. This is the mantle part. Now, this is supposedly the crust, and obviously the lithosphere also includes the crust and the upper part of the mantle. So, he says there are like as we have when you even heat a water, you see the convectional currents forming, right? Similarly, he says that over here, let us say this part is what is warm, basically because of the temperature, it basically rises. As it moves up, because the temperature over here is relatively cooler, it basically forms a convectional current where the sinking takes place, and then again this movement and this convectional current is formed, right? This is basically taking place inside the mantle. What does he say is, because while the convectional current is formed, this movement basically pulls this lithospheric plate also along with it, because the convection current that is moving is exerting a lot of force. Now, this forms the basis of your plate tectonics theory also, which we will read. So please understand. We'll come back here again. Now let's see. The Earth's mantle is a layer of semi-solid rocks beneath the Earth's crust. This is the view of what? Hess. Now, within the mantle, heat is generated by the radioactive decay of elements. Again, there are radioactive elements, so that is why a lot of heat is being generated. Now, what is there is heat generated in the mantle creates a process known as convection. Obviously, there is heat generated, so convection, something which is heating will rise. You will see this in the climatology chapter also. You will see when you are heating water also. So when something is getting warm or heated, it will rise. The hot, less dense material rises up. Now, if you see here, this is a hot, dense material. It will rise. Hot because of the temperature from the core, outer core. And obviously, if it is heated, then it will rise. So it has risen over here. Now, this process of rising over here is known as upwelling over here also. See here. The hot, less dense material rises upwards. This is known as upwelling. You will see similar concept in oceanography also. Just understand this concept. Now, this is what? Rise. This rise that is taking place is known as upwelling. Now, what happens is, while the cooler, denser material sinks downwards, now this basically will move this part, and after some time it will move down, obviously, because it has cooled. So this is what? Moving down. This is known as downwelling. But the thing that is important is, during this process of upwelling and downwelling, the movement of this mantle or these convectional currents within the mantle leads to these slabs or these lithospheric layers being pulled. This is what is being explained, and this also forms a core of the plate tectonics which is studying. See here. The convectional currents are responsible for the motion of the tectonic plates or the lithospheric plates which are being studied right now. This is the concept of convectional current theory. Just remember that. It is very simple, very easy to understand. Again repeating, see, this is a region because of the heat that is supplied by the radioactive decay. Over here, the temperature rises. So let us say there is this upwelling process will rise, or there will be rise of the material because it is heated. It will rise, move up. It will further move, and then because it has risen to the higher height, so what will happen? It will cool, and after that cool, it will sink because it has already cooled. So when it will be sinking, this is known as downwelling. While this process of moving from upwelling to downwelling, this movement of the material exerts a force on the layer that is above that is the lithospheric layer, and it basically, along with this movement, this layer is also pulled. That is why they say that the lithospheric layers are moving, because of the pressure that is exerted, the force that is exerted by the convectional currents that are moving inside the mantle. This is what is mentioned by Hess. Clear? Now there is another concept which again forms the basis for the plate tectonics theory. Please understand, if you want to understand the plate tectonics, you need to know the concept of continental drift. There are errors, but still the concept was important. Second is the concept of convectional currents, which is again important. Third is the concept of seafloor spreading. This again is important to understand. This forms again the basis for the plate tectonics. See, seafloor spreading by again Harry Hess. Okay, quickly write the heading. So everybody, please remember this. The concept of seafloor spreading is given by Harry Hess. The concept was earlier given by Arthur Holmes. One more thing, there are certain books which have even mentioned that convectional currents theory has already also been explained by Harry Hess, but the first person who has given is Arthur Holmes. So just please note this. In certain books, what is mentioned is that Harry Hess has also contributed, but the main person who has given this theory initially is Arthur Holmes. Certain books even mention Arthur Holmes and Harry Hess, but please note this. This is again a concept that is like a correction only, you can take it, but mention Arthur Holmes over here because this is the person who has first or the majorly contributed over here. Okay, let's move ahead. Concept of seafloor spreading by Harry Hess. Now this concept is exclusively, majorly or primarily given by Harry Hess. Now let's see here. What is the main purpose? First of all, in 1960, Harry Hess gave the unique concept to explain the mid-oceanic ridge. If you ever see, let us see here. Let us go to the map of the world. Over here, you will be seeing that there is a mid-Atlantic ridge that is present over here. So there are mountains inside what? The Atlantic Ocean and chains of them. And new mountains are continuously rising, volcanic activities are also going on. Similarly, in other parts also. So the problem that arises, how is this concept basically working? So always that was a point of curiosity in the minds of the people also. So please understand what happens is, seafloor spreading. So he wanted to explain the mid-oceanic ridges. Similarly, in other parts also of the world or inside the oceans, you realize there are certain mid-oceanic ridges present. But in Atlantic Ocean, you can very predominantly see them. So he wanted to explain the reasons behind them. Statement. He postulated that mid-oceanic ridge was located on the rising limb of the convectional current. Rising limb of the convectional current. Now see here. That is why I am telling you, both of them, Harry Hess and Arthur Holmes, both have contributed directly and indirectly to both the theories. But for convectional current theory, first at Arthur Holmes, then possibly Harry Hess. But for seafloor spreading, again, the main person is Harry Hess. Indirectly, obviously, Arthur Holmes has also contributed. This is a mid-oceanic ridge, right? Over here, it is saying that because of the upwelling processes that are taking place, it is leading to, let us say, what? Possibly new material, or let us say basaltic outcome that is taking place, right? So basalt is coming, basalt formation will take place because of the outpour of what? The magma. Magma will come out in the form of lava. So that means it will lead to formation of some ridge-like structure over here. So what is being said here? That mid-oceanic ridges were located in the rising limb of the convectional currents. So this is a rising limb. So what is going on? This basically will lead to certain outpour. Why? Because this force will lead to this lithospheric plate basically pulled or moved towards or inside the mantle. This will get destroyed. So further, this mid-oceanic ridge is basically creating new lithospheric plates, or the crust, in a way you can say. So please understand this. Rise of the convectional currents, tensional forces on the surface, spread on the opposite direction, spreading point. What does it mean? Rise in the convectional currents, tensional forces on the surface. This exerts force on the surface, which will lead to it moving this way. And then the output that is taking place from the magma will lead to the formation of new substances being deposited here and new lithospheric plate, or let us say these new crustal formations taking place. Spreads in the opposite direction. So because this convectional current will pull the slab inside, and new output that will take place will form new lithospheric plates over here. This point over here where the spread is taking place is known as the spreading point. This is known as the spreading point. We will be getting to know or understanding this better when we will be doing the plate tectonics. So you can see lithospheric plates are over here, crustal plates also you can say, because again lithosphere basically forms crust and the upper mantle part. So this is being new crustal formations are taking place, and over here they are getting finished because it is again moving inside the mantle. Slowly it will deform, right? So this is known as the spreading point. On the other hand, please see, places of the descending convectional current, that means the places of the descending convectional current, basically over here compressional forces are taking place. Why? See here. Over here already a lithospheric plate is there. This plate is moving thisward. So there is compression that is taking place. Descending crustal material. So this crustal material will further move inside what? The mantle, and slowly it will just diminish or vanish because of the high temperature that is there. So this region is known as the subduction zone, where one plate is moving or subducting another under another plate. So this is known as subduction zone or point. Where it is spreading, it is known as spreading point. Where one plate is moving under or subducting another, it is known as subduction point. Now, please understand, That is why you will see the convectional currents basically focuses on the internal part. Seafloor spreading is talking what is taking place on this part. Both of them are intricately linked. That is why in the various books you sometimes see convectional current and seafloor spreading by Arthur Holmes and Harry Hess. They might combine both of them because both of them are very closely intricately linked. Convectional currents focuses on the internal mechanism and what is going on. Seafloor spreading talks about the external part, obviously in reference to the internal part. Clear? Next, the crustal materials are spreading from the mid-oceanic ridges. So this is a ridge, this is spreading outward. The sea floor is moving on either side is known as sea floor spreading. So you can say, let us say if it is inside the ocean over here, this is moving. Supposingly there is a volcano over here, there is a, let us say a volcanic like substance or some structure over here. After a few years, possibly what will happen, this what was present here will reach this. Why? Because new crust are being created or lithospheric layer are being created, it will move apart. So that means there is movement that is taking place away from this particular region towards the other side. So that means from the mid-oceanic ridge, the sea floor is basically spreading outward. Now this is known as what? The sea floor spreading. Clear? This is known as sea floor spreading. Let's move ahead. What is the evidence over here? Now, the most important thing is understanding the concept. Yes, there might be spreading of the ocean and seas. That is fine. But what is the evidence? The most important evidence is with respect to the magnetic properties. Now, see here. Supposingly, there is again upwelling taking place. I've shown you just the upwelling part, now the downwelling. So, this is a limited part over here. Now, let us assume there is a again outpour of what? Magmatic substances taking place. Now, what happens is the magma which comes out, it is known as lava. It has what? Iron, nickel and all. Magnetic substances are present. Now, when they are at such a very high temperature, they come out. What is the direction of magnetism present on the earth during that time? They basically align themselves in that particular direction. Supposing in North Pole and South Pole is present. When the substances or the lava comes out, those iron and nickel basically will align themselves according to the magnetism or magnetic properties of that time of the earth. One more thing that has happened is because of the convectional currents direction sometimes changing inside the core also and mantle also, there can be a possibility where reversal of the polarity takes place. That means North Pole becomes South and South Pole becomes North. Now, this has been observed in the sea floor. Supposingly, let us assume that magnetic material have come out in the form of iron and nickel and they have aligned themselves in this direction, right? Because the magnetic properties or let us say the direction of magnetism was in this direction. But let us say a few thousands of years ago, it was reversed. So possibly they will align themselves in this direction. So because it is moving apart, you will see there is an observation that there is differences in the polarity that is present here. Now, this was very, very confusing why this happened, but this can be observed through multiple means. First, if you basically do the dating of the material that is present here, it will be young. If you date this substance, it will be very old. That means this is being created of late and this has been created very late. That is why this is very long ago. So that is why it is basically moving apart. Polarity reversal is also an indication which you can match that supposingly long time, let us say few thousands years ago, there was reversal in polarity. And similar thing you note it over here. Similarly, let us say few thousand years ago, before that, there was reversal in polarity and you can note it on the mid-oceanic ridges region around that. That will give you an idea that means the reversal in the magnetic properties reflect the magnetic properties or the direction in the mid-oceanic regions and surrounding them. So the outcome is that in a way you realize that there is a spreading of the mid-oceanic region, or that means spreading of the sea floor is basically taking place. Now this was a breakthrough that took place. That is why it forms a very, very important ingredient. So see here, the survey of the mid-oceanic ridges for the magnetic properties was done. Alternative bands of normal and reverse polarity were found in either side of the ridge. Now this was correlated with the times when the magnetic or reversal took place, and it was found exactly the same. And after some time what happens? Again new magnetic substances are coming and they're moving apart. And dating methodology also helps us that this is young, this is old, because over here new crustal formation will take place and these by that time will move ahead on this direction. So these are old. So in a way we realize that the sea floors are basically spreading or moving apart, an outcome of the convectional currents. So this was an evidence, most important evidence that took place, which we will even see in the plate tectonics theory. Let's move ahead. Plate tectonics theory by Mackenzie and Parker, 1967. Please see here. This theory tries to explain the dynamic movement and interaction of the Earth's lithospheric plate, which makes up the outermost layer of the planet. Now see, lithospheric plate movement, what is the reason, why it is taking place, what are the mechanisms, everything. He wanted to understand and explain them more comprehensively, because the theories which had come prior to that have also done their part. Seafloor spreading, convectional current theory, continental drift has explained its various dimensions, but they were not able to satisfy it completely. So that is why this theory came. It is again, this theory is said in the form of theory, but it itself is not a theory, because it basically takes up all the concepts of convectional current theory, seafloor spreading, in order to explain this particular theory. So this theory tries to explain the dynamic movement and interaction of the Earth's lithospheric plates, and which makes up the outermost layer of the planet. Now, definition first of all. The rigid lithospheric slab or rigid or solid crustal layer is technically known as a plate. Right, so lithospheric plate or plate. Now the plate you very well know over here, lattice means the basically a lithospheric plate, which means the crust as well as some part of the upper mantle, right? What is plate tectonics? The whole mechanism of evolution, nature and the motion of the plates that is taking place is known as plate tectonics. So everything, what is the nature, how the movement is taking place, how it basically evolved, how it is created or destroyed, what are the things that are created during the process of this movement, is everything covered in the concept of plate tectonics. So this is the definition. Now, basis of the theory, first of all, we will not be repeating these theories, but see, first is continental drift theory by Wegener. Why? Because he at least gave the view that there are some movement of continents taking place. Though over here we realize that the plates are moving, not continents, but it formed the basis that some movement is taking place. That is why the conceptually continental drift theory forms a basis. Second is seafloor spreading by H.H. Hess. When I mentioned about seafloor spreading, please remember that when I'm talking about seafloor spreading, it also covers the concept of convectional currents theory by Arthur Holmes. So if you want, you can write seafloor spreading and convectional current theory by Arthur Holmes and H.H. Hess. In this way also you can mention, there is no problem. But when I mention seafloor spreading, it is by default covering the concept of convectional current theory. Now see, driving force or the mechanism. Now the question comes, from where is this energy coming, which is basically moving these plates? So the plates are in constant motion, driven by internal heat generated by the radioactive decay in the Earth's mantle. Now, the radioactive decay in the mantle is basically a cause for this energy being generated, and that is resulting in convectional currents. Now, this convectional motion of the mantle, mantle convective cells sets the plate in motion. So again, convectional current. What is present in seafloor spreading also we had studied. So the radioactive decay is generating the energy. This convectional currents is basically leading to what? The convectional current cell being created. What is a cell? What is a cell? This is a cell. This is a cell, right? A closed packet over here being represented. So these are convectional cells that are generated. Now these motion of the convectional currents basically lead to what? The plates or plates moving on the surface, right, on the mantle. So this is the driving force. So you should remember two things. First is the radioactive decay. Second is the convectional currents that are leading or causing the plates to move, right? Let's move ahead. Tectonic plates classification. Here again, please understand, we will not go into the mechanisms because we've already studied the convectional current, seafloor spreading and continental drift. We know the exactly same based on the concept we have done, the movement of the plates are taking place. Now we will classify them because this is again important from the prelims as well as the mains perspective. If I classify based on the geometric aspect, I can classify the plates 7 major plates and 22 minor. We do not have to remember all minor plates, I mentioned few, but major you have to remember. Major plates are the North American plate, South American plate, African, Eurasian, Antarctican, Pacific and Indian Australian plate. Minor, you have the Arabian plate, Nazca plate, Philippines plate, Scottish plate, Cocos plate, and so on and so forth. There are multiple plates, which you should have an idea. These are the important ones. Based on the kinematics, how the movement is taking place, there can be convergent boundaries, there can be divergent boundaries, and there can be transform boundaries. You have little bit knowledge based on what, while I was teaching you the convectional current concept, you have little bit knowledge about these things. But please remember one thing, we will be studying over here in detail, so it will become easy for you to comprehend. Clear? So these are the three concepts which we'll be understanding. So let's first of all understand this thing. There are major plates also present over here. There are minor plates also, few of them present here. Unlike the continental drift theory, where they said that, let us say, the African continent is only moving, and only, let us say, the South American continent is only moving, that was wrong. What they basically said is, when the plate is moving, it is not only the continent. These are huge plates that are, let us say, present. This plate as a whole basically move. It is not only the continent. The only problem is, in continental drift theory, they assume that because this continental part is visible or above the water surface, so only this is moving. No, it is a complete part as a whole which is moving. So when the plates are moving, it is also the oceanic part also that is covered in them. Please understand that. So it is not only the continent part or the landmass which is visible above the earth that is moving. No, it is this complete plates that are moving. They might be subducting or whatever be the case, we will be seeing them. So this is African plate. This is what? The Eurasian plate. This is the Indian plate. This is the Arabian plate. This is the Australian plate. This is the Pacific plate, then minor plate of Philippines. Then you have the Antarctican plate. You have the Scotia plate. You have South American plate. This is the Cocos plate. This is the Nazca. Again, these are the minor plates. You have another minor Caribbean plate. Then you have Juan Foucault plate. This is again a minor plate. North American plate, again a major plate. So these are the plates that are present. So this is a difference from the continental drift theory, which says only continent moving. No, the plates are moving. Plates might cover the regions of the continent also and the ocean also. That was neglected by the theories of continental drift. They did not consider the oceanic part. Clear? So this is the first part which we have seen being presented here. Now comes the part of kinematic aspect. Let us see one by one. When I say about divergent boundaries, please understand, you mostly observe this in the mid-oceanic ridges. Why? Because in this particular region, due to the convectional currents, new crustal formation take place and the plates are moving apart. Divergent plane boundaries, that means plates are diverging. They are known as constructive. Please understand, divergent plane boundaries are constructive in nature. Why? Because when the plates are diverging, because of the pressure due to the convectional currents, there will be new material that will be coming out. It will be deposited and further new plates will be formed. Lithospheric plates will be formed. So that means construction is taking place. That is why divergent plate boundaries are known as constructive in nature. Now you know that this divergence is taking place because of why? The convectional current cells that were there. Because of the convectional currents cell that were there. So when a new crust is generated, as the plate moves away, new crust is generated here as the plates are moving away from each other, the site where the plates are moving away from each other are known as the spreading sites. This is what? The spreading site. Clear? Now this can happen in various dimensions, various places. You'll see this. Divergence, that means there are plates, so there is convectional current taking place, so this will move apart. When it is moving apart, because the convectional currents are there, further magma in the form of lava will come out and it will be deposited. Now what will happen will lead to further crustal formation, a new lithospheric plate or a part of it being created. So there is construction taking place. That is why it is known as constructive in nature. Divergent is associated with construction. Clear? Similarly, if you see oceanic divergence, what do you mean by oceanic? If there are two plates which are inside the ocean or ocean plates, they are moving apart. What will it lead to? It will lead to mid-Atlantic ridge. This is an example in the Atlantic Ocean or mid-oceanic ridge, you can say. So oceanic divergence is taking place. That means within the ocean, if there is divergence taking place, there will be outpour, and it will lead to what? Mid-oceanic ridge, or one example is the mid-Atlantic ridge, which you see in the Atlantic Ocean. The ridges that are created is because of the oceanic divergence. See here, let us say this is the inside the Atlantic Ocean. Inside the Atlantic Ocean, if this convectional currents is there, these are what? Oceanic plates. Now it will move apart, ridge will be created. This is what is the scenario with the mid-Atlantic ridge formation. It is an oceanic divergence, and that is leading to the construction of what? Further lithospheric layers. That is why it is constructive in nature. Clear? Let's move ahead. Continental divergence. Now see here everybody, you would have seen the case of Africa, where this part of Africa is basically moving apart. So there is divergence taking place. So continent divergence over here is an example. Now this is example of East African Rift Valley. Again divergence is taking place. So this is basically separating, right? Divergence can be continent based also, and oceanic divergence also. Now comes the convergent boundaries. We have done with the divergence. Now comes the convergent boundaries. Convergent means basically two plates are colliding now. Now you have heard the collision taking place, but the very important thing will, which plate will move down? You see over here, we have shown that this plate is moving down and this is here. Why this is not moving down? One or rather 2 points you should always remember. The plate which is more dense in nature or more denser is the one which is going to move down. The one which is less dense will not move down. Obviously, you need more density, because that is why you will move down. The less dense will be above. Now, another first point is this, the plate which is denser in nature will move down or subduct. You have studied in the previous lecture that oceanic plates are much more dense than the continental plates, right? So whenever there is a collision between an oceanic plate and a continental plate, you will see the oceanic plates are basically subducting. Why? Because they are more denser in nature. If supposingly continent are basically colliding, in that case also the one which is more dense will be one which will be subducting. So it is a density which basically decides which one is going to subduct beneath the another plate. This is a very important concept, and you should always remember that, because many people just rote learn it and do not understand this concept. So density is the one which is deciding which plate will subduct. Subduct means which will move down. When two plates are colliding, so one will move down. So one which is going down, this is known as subduction. The region where it is going down is known as the subduction zone. Clear? Which one is going down or subducting? The English word is subducting. So that is basically the one which is more dense. Clear? Okay. So over here, let us say this plate is moving. This plate went, let us say, inside the mantle. Now it is subducting. This is known as the subduction zone, because this is more dense. Now see, when two plates move towards each other, where one plate overrides the other and the other is overridden, that means that means one is moving down, other remains in this position. A little bit changes will be taking place on this also, but the one which is basically subducting, other will be the one which is in this position, right? So one overrides and the other is overridden. Similar language in a different form. Now this convergent or convergence can basically take place in various ways and various situations. First, ocean-continent convergence. Now there are plates, one is oceanic plate, another is, let us say, continent. If they basically collide, what is going to happen? It occurs between the oceanic and the continental plate. Now let us take few landforms. Let us say volcanic arcs being formed. What are volcanic arcs? One long chain of volcanoes that form on continental plates above the subducting oceanic plate. Now see over here. Everybody. See over here. Volcanic arcs basically form a long chain of volcanoes. Now let's see, in this particular case, when we see Andes, we see the Nazca plate is subducting under the South American plate. See here. This is the Nazca plate. Nazca plate, why it is called an oceanic crust? Because it is under the ocean, obviously. This is the South American plate. Now this Cocos is basically this, remember, this is complete Nazca plate. Now the Nazca plate, this is a boundary. It is subducting under the South American plate. Now this plate is again what? A continental crust, a plate. Now if Nazca plate is moving towards the South American plate, Nazca plate is an oceanic plate. It is more dense in nature. It will be subducting or moving beneath the what? Beneath the South American plate. Clear? Now what will lead to? It will lead to a long chain of volcanoes that form on the continental plate. Now see here. See here. This is, let us say, the direction is, let us say the Nazca plate, this is South American plate, it is going on. Now over here, because this is a lot of pressure being exerted, it is moving down, it will slowly melt. It will slowly melt. It will lead to again a pressure being exerted as a counter force, and over here volcanic eruptions might take place. And chain of, let us say, volcanoes will form, volcanic eruptions will take place. That is why if you see Andes is basically a volcanic arc. Volcanic arc, a long chain of volcanoes that form on the continental plate above the subducting oceanic plate. So over here, when a plate is subducting under this continental plate, this large part of the plate over here is getting destroyed. Please understand, convergent plate boundary is also known as destructive. Why? Because over here this part is moving or subducting under, this part will get destroyed. That is why it is known as destructive. Now when it is getting destroyed or destructed, this part is moving inside the mantle. So that means it is a pressure or a force being exerted inside the mantle. It will melt. It will melt. Now you know that law of nature, for every action there is equal and opposite reaction. So what happens? This, in order to compensate this, there will be again compensatory volcanic eruptions that might take place in this region, right? Because this part of the plate has gone inside the mantle and a lot of force and pressure is exerted. So this leads to the formation of volcanic arc. Example is the Andes. Now the Nazca plate subducting under the South American plate is an example of this. Second, folded mountain range, Rocky Mountains. North American plate and Juan de Fuca plate along with the Pacific plate basically can lead to folded mountains. There is a possibility when, let's see, there's a possibility what happens is sometimes it is not necessary that in every case similar things will happen. It will depend upon the nature, the density, the pace at which it is moving. So a lot of factors depend upon whether it will be a volcanic arc forming, whether it will be folded mountains forming. A lot of situations vary upon case to case basis. Now over here if you see, this is Juan de Fuca plate, a minor plate. This is the Pacific plate. Now these plates are subducting under the North American plate. Now what happens is, please see, sometimes when the subduction is taking place, it leads to some folded mountains because the pressure is exerting. So there will be crustal folding that takes place and that leads to the formation of folded mountains. So over here when you see the example, let's see, Rocky Mountains, these are fold mountains. Why? Because there's some folding taking place because of the pressure that is exerted. So North American plate and Juan de Fuca plate along with the Pacific plate boundary. Over here you see Rockies Mountains along the North American region. Why? Because the pressure that is exerted by the subducting plate that leads to the folding of the crustal material that leads to the formation of folded mountains in this particular region of the Rockies. Now this is again example. Third is foreland basin and back arc basin. Now please understand, this is something very important. Basically you should understand, supposingly this is third landform. Please understand these three landforms which I have talked about are under the convergent boundaries under ocean continent convergence, right? Under ocean continent convergence, I've done volcanic arcs, I've done folded mountain ranges, and I'm doing foreland basin and back arc basin. What are these? Supposingly this continent, this oceanic plate is basically subducting. This leads to, let us say, these volcanic arcs being created. Let us say Andes. What you will see is this region, and there are two regions that are created. This region is known as the foreland basin, and this region is known as the back arc basin. Please understand this. This is a basic labeling. So this is again an outcome because this will be a little bit elevated because of the volcanic eruption taking place. These are two basins that are created. These are foreland and back arc basins. These are two things as landforms, you should remember them because this can be asked, because nowadays questions with regard to landforms are being asked. So you should know these two statements. Okay, let's move ahead. Now we have done ocean continental convergence and the landform. Let us see ocean convergence. Now see, it is a convergence of two oceanic plates converging. Trenches, example Marina Trench. Now if you see, if two oceanic plates are converging, now what happens? Let us assume, let's see this. Let's take an example for 2 minutes. Let's come here. Let's see. Supposingly, this is a plate. This is a plate. There is another, let us say, plate that is coming, and that is basically moving down. Now, if both are oceanic plates, the one which is more denser will move down. If you realize this, because of the subduction, there will be a lot of depth that is created in comparison to this level. See here. Because of this subduction, there's a lot of depth. This depth, or let us say that the structure of lot of depth that is created because of this at that subduction zone, this is known as a trench. These are the regions, basically regions where the subduction is taking place. So because of subduction, that leads to the folding of these plates. So that means the level in comparison to the other plates, this is much more down. It can be multiple kilometers down also. These are known as trenches. Now these trenches are why? Because inside the oceans only you will find them. So these are, example is Marina Trench. Second is volcanic island arcs. Now these are chain of volcanoes islands formed as a result of subduction of one oceanic plate beneath the another. If you see the Aleutian Islands, these are again because of Pacific plate subducting under the North American plate or North American part. Clear? Chaliye. Next is continent-continent convergence. Now, if you see the example over here, two continents converging. This is an example of Himalayas also. If you see, in case of the Himalayas, you see the Indian plate basically collided with the Eurasian plate. Yes? Now, in this case, what happens is the one which is denser in nature will be subducting under the less dense one. So, what happens is, one plate which is converging, let us say subducting, this subduction will lead to pressure being exerted and a lot of, let us say, mountain or folded mountains will rise. Because, let us say, one plate is subducting, obviously that will create a lot of pressure. It will lead to a lot of crustal folding on this or this plate, that is under which the subduction is taking place. So what happens is the folded mountains are formed. This is an example of the Himalayas also. So the Himalayas, the Indian plate and the Eurasian plate collision that took place, it might lead to uplifted plateaus like in the Colorado Plateau. So this is an example of the folded mountains that are formed in the collision of Indian as well as Eurasian plate, that is the Himalayas. So this is an example of this. Let's see, transform boundaries. Now, transform boundaries over here is basically the case where a lot of situations, two plates are neither subducting or now diverging. Or let us say there is no convergence or divergence taking place. But instead, two plates are basically, let us say, sliding along with each other. This is known as transformed boundaries. So characterized by horizontal movement of the tectonic plates sideways. So these are two plates which are basically sliding. So that is why it is conservative. Why conservative? Because neither destruction or construction is taking place. So that is why it is known as what? It is known as transform boundaries. Please note it down, all of you. It is very, very important. Next, transform faults can be formed when two tectonic plates slide past one another. It might lead to the creation of, let us say, some structures like San Andreas Fault in California. It might offset a drainage. Let us say a river is flowing. Now, a river was flowing, two, let us say, plates slide, possibly it will disrupt the drainage pattern or the way in which that rivers was flowing. So this is again an offset drainage. Example, the Owens River in California. So these are two most important things. Last is mantle plume. Mantle plumes, please understand. Let me show you a diagram. These are basically the diagrams which you see. This is the core. From core, you will realize that these mantle plume rise. This is a tail, this is a head. This is a riding plume. Further, it might move up and lead to formation of, let's say, basaltic flood. And later on, because the plate is moving, this part will move further forward, and similarly other products, or let us say other eruptions that have taken place will lead to further, let us say, islands being created, and this is a basic concept. Let us see, understand this concept. Based on the diagram only, we'll explain you. See, what happens is, these are narrow vertical columns of hot, buoyant rocks that rise from the Earth's mantle to the crust. So, because the from the energy that is generated because of the radioactive decay and all, you will realize that vertical columns of hot, buoyant rocks, you know that basically we're talking about magma, will rise and that will move upwards. Though they are thought to originate deep within the Earth mantle, specifically from the boundary between the mantle and the outer core. Now, there are a lot of assumptions whether it is rising simply from the mantle or obviously it is going to cross mantle, but the assumption over here is that it is rising from the part of the core, and then this plume is rising, this vertical column is rising and reaching the surface. It consists of hot molten rocks, magma, and solid rocks that are partially melted. The radioactive elements and the reasons for this basically plume basically rising. Now what happens is, these plumes can lead to volcanic hotspots such as the ones which are responsible for the Hawaiian Islands. Now please understand this concept for 2 minutes. The actual reason why certain regions have plume and other regions do not have, there is no explanation for that right now. It is possibly because of the nature of the places where possibly these magmatic eruptions are taking place. There is no correct explanation for that. But what we see is certain observation where these hotspots are formed. From the core of the mantle boundary, this vertical column basically rises. This is again very hot magmatic substances that rise. They basically reach the surface. Now, what you have to understand is, this yellow part is a lithospheric plate. Now, this is continuously moving, but this position of the plume is fixed. Supposingly, what happens is, this plume rises because this plume, when it rises, it will try to lead to this magma basically coming out, and that will be spilled on the surface of the plate. Clear? Now, this plate will further move ahead. So that means, let us say this plate has moved ahead, this part of it has reached here. But again, the magmatic eruptions from this hotspot will keep on coming. So again, possibly over here, you will see certain islands being created. This will again move ahead. So that means plume's position is there. Any plate that comes on top of it, there will be volcanic eruptions, or let us say magmatic outpour, and that let's say landform is formed, an island is formed, and then the plate further moves. That is why, if you realize, Hawaiian is basically an outcome of this particular hotspot. Similarly, if you see, you would have believed that, so how come there is so much basalt, or let us say the Deccan trap that is formed, right? There's always a problem that question that how come this Deccan trap is formed in the peninsular region. Please remember, when the peninsular part was moving and coming, or let us say coming close to the Eurasian plate, much before that, it basically crossed a reunion hotspot. So that means, supposingly, when this is, let us say, the peninsular part, when it came on top of the reunion hotspot, during the Cretaceous period, there was outpour of lot of magmatic or basalt that came out. Later on, this plate further moved ahead, right? It moved ahead and later on collided with the Eurasian plate. But during the Cretaceous period, when those basically magmatic outpour took place, that basically led to the formation of the Deccan Plateau or the Deccan Trap, right? So that means, when it was on top of the reunion hotspot, those volcanic basalt outcome took place, and later the plate moved ahead. Now see, let's see here. This is supposingly, let us see, let's take this. Supposingly, this is the mantle plume and this is the hotspot. When the Deccan Plateau was on top of it, while it was moving because of the tectonic movements, during the Cretaceous period, outpour took place in all these regions, and that means that led to the later on formation of the Deccan Trap. But this plate kept on moving, and later collided with the Eurasian plate. So that is why the answer is that the Deccan Plateau, though there is no volcano underneath it, but how come that igneous rocks are found here? The reason is because it crossed this particular hotspot, that is a reunion hotspot, and that led to this known as the igneous rocks being present in that region. So this is because of these plumes and the hotspot that we basically study here. Clear? Another last concept that we study is Pacific Ring of Fire. Pacific Ring of Fire, this is an representation. First of all, let's see. Pacific Ring of Fire is a tectonic belt of volcanoes and earthquakes. This is a region where, because of the continuous plate movement, there are a lot of volcanic eruptions and earthquakes that take place. Now, this is about 40,000 kilometers long and up to 500 kilometers wide, surrounding the Pacific Ocean. Now, if you see this belt that I have drawn is a region which is known as the Pacific Ring of Fire, which has massive earthquakes, which have massive volcanic eruption taking place because a lot of subductions and plate movements are taking place. So this is known as the Pacific Ring. Now, over here you will see convergent plate boundaries where volcanic arcs like Andes of South America, subduction of the Nazca plate and the Antarctic plate under the South American plate. You will see the Himalayan subduction of the Indo-Australian plate under the Eurasian plate. Hotspot, you will see the Hawaiian island being found. Transform boundaries, obviously there are, along with the subduction and divergence spaces taking place, there is also transform boundaries that are there. So example is San Andreas Fault. So what we see is, in these particular regions which you see, a lot of tectonic activity is going on. Because of that, when there is tectonic activity, there will be by default, outcome will be earthquakes and yes, volcanic eruption because these are weaker zones. That's why this is known as Pacific Ring of Fire. Clear? So we have done with this important topic. This is quite a lengthy topic and quite an important topic also. We have covered almost every aspect over here. Certain things will be covered in the other topics also, because we are arranged in such a manner that there is coherence and proper understanding. So we'll be doing the volcanoes also in the landform chapter, not over here. This is a complete understanding of the distribution of ocean and continents, which you are required for your prelims and the mains. Now, please understand. Based on what I've taught you, you will see, if you see the PYQs, the question has come, Pacific Ring of Fire, why it is a zone where a lot of earthquakes and volcanoes are found. You know the plate tectonics theory and this diagram. Question has come, explain the continental drift theory with evidence. You know the Alfred Wegener's theory with evidence I've given. Also, you can mention in brief about the Tyler's theory. They've also asked you what is, let us say, plate tectonics theory in the previous year question. You can explain that also. You can use the plate tectonics theory to explain now how volcanic eruptions possibly taking place, how the Himalayan formation is taking place, and so forth, the volcanic arcs, how they are forming. All these things have been explained. So if you read and go through the content well, listen to the lecture well, you will be able to answer all of them. So this was the lecture from my side. We'll be coming with the next lecture. Take care, God bless and Jai Hind. If you like the lecture, please rate it, comment in the comment section, let us know. Bye and Jai Hind.